This is our 48th video tutorial under the GCSE topic revision guide called Distance Time Graphs. On this topic, you need to understand the distance moving away from a starting point and after that taking a break or moving away, further away, or coming back to the starting point, that kind of concept. So if you understand one or two questions, that's more than enough on this topic. This topic may helpful for your physics question as well. Let's look at the exam style question and the theory same time. Hello everyone, this is the tutorial we are going to discuss in this video session. You can download this tutorial from our website at www.smart-tutors.co.uk/worksheet.php. Under the Year 11 section, you can download the tutorial. Our annual membership is £24, allows you to download the tutorials in PDF format. If you want the predicted papers and past papers, also very helpful, you can be a member and download the tutorials. Let's look at the exam style question. Our question number one. Question number one, Alex drove 60 kilometers from his home to London. He stopped and visited his friend Mike on the way, and finally he drove back home. Here is the distance time graph for this journey. First question, how far was Alex from home when he visited Mike? First of all, we need to understand the graph. First of all, 9 o'clock he started the journey. At 11 o'clock he traveling in a constant speed and reached 30 kilometers. Then he stopped for 1 hour. Maybe this is the time he met Mike, his friend. Then after that he is going constant speed again, that is moving away from the starting point and reach 60 kilometers. So the 60 kilometers is where the London. So from London then you are returning to the starting point to his home. So the 60 kilometers back at 2 o'clock he is returning home. That is the typical graphs explanation. So here the important point you need to know, the gradient of the distance time graph gives the velocity, and if you stop, that means the distance is not moving, the time is you're spending time. So here 1 hour he spent at Mike's place or somewhere, they had a chit chat. So first question, how far was Alex from home when he visited Mike? The answer is 30 kilometers. How long did Alex stop for? I can say 1 hour. Question number C, how far was London from Alex's home? 60 kilometers. What is the speed of Alex's return journey? So Alex's speed return journey means, so you need to make a right angle triangle, and this is the right angle triangle, and here 12:30. So this is 12:30 and to 2 is 1.5 hours, right? And this is 60 kilometers, right? And the speed equal distance over times. So distance 60 over 1.5, right? So which is going to be 600 over 15 is going to be 40. So 40 kilometer per hour. That is the unit for the speed. Question number 2. Anna traveled from her home to her friend's house 15 kilometers away. She stayed for some time and then she returned home. Here is the distance time graph. At what time did Anna leave home? So here this is 14:00 means 2 o'clock, so 2 p.m. here, and here 2:20. So 2:20 is 10 boxes, 2 minutes every, so 2, 4, 6, 8, 10. So this is 2:10. So 14:10. So that is the answer for the question number A. Question number B, how far was Anna from home at 14:30? So 14:30 means, so this is 14:20 and 14:30 is this one. So this is 10 kilometer. So that is the answer. So 10 kilometer. How long did Anna spend at her friend's house? So the friend's house, this is where she stopped. So let me draw a straight line, then easy to calculate. So from here is 1440 and from here is 15 o'clock. So 1440 to 1500 is 20 minutes. So the answer for the C part is 20 minutes. Question number 3. The first 5.5 hours journey of a cyclist is shown in the graph, right? What could this graph represent? So distance versus time is given. So if they ask this as a kind of a common what happened or what do you think about this graph, and explain the graph's journey and everything. So you need to understand the topic, what you need to do step by step. So first step, between 0 to 1, what happened? So between 0 to 1, so the cyclist, right? Cyclist moving a constant speed, right? So cyclist traveling at constant speed away from the starting point. And between 1 to 1.5, so cyclist having a break. Then next one, from the 1.5 to 2.5, so what's happening is cyclist moving further away from starting point. And from the 2.5 to 3.5, cyclist having a break. Then from the 3.5 to 5.5, cyclist returning to the starting point. Returning to the starting point. First question we already done. Second one, B, how far was the cyclist from the starting point when he had the first break? First break, how far is 4 miles? Actually it's miles, but I just cancel this kilometer. Distance in miles, 4 miles. Second question, how long did the cyclist stop for? So they didn't ask for which stop. So the total stop is here half an hour and here 1 hour, altogether 1.5 hours. Question number D, how far was the cyclist from the starting point when he had the second break? Second break is 8 miles. What is the total distance traveled by the cyclist? Here we have to be very careful. The total distance means from here to starting point, from the starting point until he is going 8, and the returning journey is another 8. So 8 plus 8, 16 miles is the answer. Question number 4. Here is the part of the travel graph of Nisha's journey from her home to the gym and back. Work out the Nisha's speed for the first 30 minutes. So the first 30 minutes is here. So this is the first 30 minutes graph. So if you make a triangle, that is the triangle, and the speed equal distance is 10 kilometer divided by 30 minutes. So 30 minutes means half. So swing back 20 kilometer per hour. So 20 kilometer per hour is the answer. B part, Nisha spends 40 minutes at gym. He then travels back to his home at 40 kilometer per hour. So Nisha spent 40 minutes means, so 30 to 40 is 70 is here. And he then travels back to his home 40 kilometer per hour. So speed equal distance over time. Speed is given 40, distance is 10, and the time is t. So cross multiply 40t equal 10. So t equal 10 upon 40. So that is quarter. So quarter means 15 minutes. So 15 minutes he takes to go back to his house. So 70 here and 85 is this the minutes, and we are going to draw a line connecting 70 to 85. That's it. So what is the total distance traveled? So 10 plus 10, which is 20 kilometer. So that is the answer for the question number 4. Question number 5. Every morning Tom walks along a straight road from his home to a bus stop, distance of the 160 kilometer. So altogether 160 kilometer he need to travel to go to the bus stop. The graph shows his journey on one particular day. Find the velocity and explain the journey during the following time. So 0 to 50. So 0 to 50 means here to here 0 to 50. Right? So now 0 to 50 means what is the velocity? So velocity equal distance 100, seconds 50 is going to be 2 meter per second. So 2 meter per second velocity. Tom is traveling away from his home. Right? So 50 to 70, what's happening? For some reason, he is returning to the home. So he is like basically he's starting from, this is his home, and he's going for 100 meters. So this is 100 meters. So from that point, he's going opposite way for nearly 60 meters. So he's going for 60 meters to somewhere shop or something. Then from there, he's going from 120. From here, he's traveling 120, which is further 60. So to reach to his bus stop or somewhere. So that's what happening. So 50 to 70. So the velocity is, right? So distance traveled is 60. Am I right? So 60 divided by 50 to 70 is 20 seconds. So if you cancel everything, 3 meter per second. So Tom is traveling towards to his home at the speed 3 meter per second, which is understandable. 70 to 100. So 70 to 100, what's happening? So we need to find out the velocity first. 70 is 160. So 160 take away 40 is 120, divided by is 70 to 100 is 30. So this is 120 divided by 30 is 4 meter per second. So 4 meter per second. So Tom is traveling away from starting point at 4 meter per second. So from 100 to 120, so velocity is what? Is 0. So what's happening? Tom is having a break or what? So he's going to the bus stop and Tom is waiting at the bus stop. So E part, how long did Tom take to reach the bus stop? How long to reach the bus stop? 100 seconds. So 100 seconds he took to reach the bus stop. That's the question number 5. Question number 6. Raj leaves homes at 13:00, that means 1 p.m. He drives at an average speed of 60 km per hour for 2.5 hours. He stops for 30 minutes. He then drives home at an average speed 50 km per hour. Show this information on a distance time graph. So first of all, 13:00 is going to be the starting point, right? So 13:00 is going to be the starting point. And now this one is going to be the 14:00. So this is going to be 15:00. And this is going to be 16:00. 17:00. Then 18:00 and 19:00. Right, so 13, 14, 15, 16, 17, 18, 19. So that's the timeline. So that's the time in hours, h, and the distance in kilometer. So distance in kilometer. Right, so first of all, speed equal distance over time. So speed 60 kilometer equal distance over 2.5. So 2.5 times 60 is distance is 150 kilometer. So he travels 150 kilometers. So if I say this is 20, 40, 60, 80, 100, 120, 140 and 160. So 150 kilometer is somewhere here in the middle here. So 2.5 hours. So 2.5 hours means 330. So 2.5. So somewhere here. So let's draw the curve here. So 150 somewhere here. So right. So now it's going to be travel half an hour. So 3:30 to 4 o'clock he's stopped for 30 minutes. So then from there he's going to travel. So if I draw, this is going to be 2.5 hours, and if I draw this one is exactly 4 o'clock. And now what we want to do, and he's going in average speed is 50 kilometer per hour. So speed equal distance over time. So 50 equal distance over time, we don't know. So distance is, we know, roughly 150. So 150 over time. So 50t equal 150. So T equal 3. So T equal 3 hours means so 150 you need to travel 150 kilometers, and 50 is the speed, and 3 hours from here. So 4 o'clock to 3 o'clock, 3 hours is 7 p.m. So you need to connect a line from here to here. So that is the distance time graph. And now the question is, a film start at 6:45. Does Raj get home in time for the start? No. So the answer straight away no, because time equal 3 hours from 16. Raj will reach home by 7 p.m. So that is the answer for question number 6. Question number 7. Shown below are 6 distance time graph, and each sentence below describes one of the graphs. Write the letter of the correct graph next to each sentence. Mr. Ben travels to work and immediately returns. So travel to work and immediately return means graph F. Mr. Ben leaves home and travels to work at steady speed. Mr. Ben leaves home and travels to work at steady speed. So I will say A. Mr. Ben leaves work and travel home at steady speed. So I would say D. Mr. Ben stays at work. So he's staying at work, C. Mr. Ben leaves home and travels to work, stopping at the shop on the way. Stopping at the shop on the way. So B. Then left is E. Mr. Ben traveled to work, stay there for some time and returns home. So we made some mistake. Mr. Ben travels to work, stay there for some time and return home. So that is going to be B. Mr. Ben leaves home and travels to work, travels to work, stopping at the shop on the way. So that is the E part. So this journey clearly explains, so he moving from home and he traveling and stopping somewhere in the shop. Then after that he further traveling to his office work or somewhere. So that is the typical distance time graph, which asks you to match the scenario with the graph. And I think that is the end of our tutorial. I hope you like the video, and if you do like the video, please give us a thumbs up and subscribe to our channel. You can download this tutorial from our website at smart-tutors.co.uk. The membership allows you to download all the tutorial in PDF format and the predicted papers. Thank you for your time.